Hello everybody. So for the one they see my video without going through my website, so for those who find my video without going through my website, let me introduce myself. My name is Gilles Urtubise, and my self-taught and multidisciplinary and inventor scientist name is Gilles Lauzon Urtubise, and I am the owner and the founder of the first human multi-intelligence.com. So yes, so just a couple minutes today about my ENT health problems. Then I lose all of my day yesterday because of this, because I have to treat myself during all day. So yesterday it's about 8 hours of which I feel weak and which I cannot do in video because I feel too weak. So so here for all the person they suffer like me about ENT health problems, I should tell you that I buy this, and this is for to clean my tube of ears, the tube outside. So because that's helped me with hot water, not too hot but hot enough, and with soap. I put a soap in my tube of ear. So and after this I rinse with hot water. So this way that's helped me a lot to clean my ears, and that's helped me a lot to clean all of my area of ENT health problems. So and sometimes even if I use all of my tricks to treat me, sometimes it's not enough, like yesterday, to keep going well enough to doing video. So other treatment I had to do, it's to wash my eyes, well over of my eyes, with soap and water, and here in my neck and and both sides of my mouth, the same things, all of these here and all of that too. So and I use soap and water, hot water to clean it by outside much as I can. So and with these bottles that help me a lot to clean my ears by outside. So usually, and after I clean all the best as I can, I used to apply a cream like Vicks or the similar products, which is about the same recipe. Then so I put Vicks, the cream of Vicks over here, over there, and over here to cover all of my sinus. To put pressure on them to remove the mucus inside. So the mucus, and much as I can over here too. So and after I put the cream, I have to wash again before doing video and get a shower. After I go out the shower, I start back again to put cream, and I used to do most of the time the video with the cream on my eyes, on the skin that cover my eyes. So and all over here, and some of there too on both sides. So in this way I can be good enough to work about 2 hours without too much inconvenience. So that it is for my ENT problem. So go back to the astrophysics video. So yes, I'm doing this sometimes in my video because I need help from a surgeon, medicine man, to remove my lymph node, my infected lymph node, which is right there, and which is keep my problems continue and to becomes chronic health problems then. So okay, go back to the astrophysics video. process responsible for producing solar radiation, part 2. Okay, so why the suns produce these radiation, these solar radiation? So, well, the sun have the zone of the photosphere, which is about 400 kilometers thick, and has a temperature that varies between 5, starting supposed to start at 5,781 Kelvin at the surface of the sun, and the average temperature of this zone is supposed to be 4,000 kelvins, and until at its outer border. So, and the internal temperature of the sun is approximately 15 million Kelvin, or little less of Celsius degree, or degree Celsius. So it cannot be just, for me, it cannot be just only 5,781 Kelvin on its surface, because the photosphere is a very thin outer area and immediate outer night bore of the sun. So this part, all the scientists, they think that that's a part of the sun, but for me it's not a part of the sun. It's something's out. It's something's out, and they have no connection. But this is the immediate zone behind the surface, which is covered the surface with is 400 kilometers then. So, and the sun have another zone in its atmosphere. It's the chromosphere zone, which is about 2,000 kilometers thick and has a temperature that's vary between, at beginning, 4,000 Kelvin at the border of the ends of the photosphere zone and the beginning of the chromosphere zone, which increased to about 1 million Kelvin at the border of the ends of the chromosphere zone and the start of the crown zone, solar crown zone then, with an average temperature which is about 100,000 Kelvin. So, and another area of the area of the solar crown, which is thickness is about 482,082 kilometers thick. It has a temperature that varies between 1 and 5 million Kelvin. So of course, at the beginning of the solar corona, which is the zone in white here, at the beginning the temperature should be the lowest one, and at the end should be the highest one, which is 5 million degrees. So then between its border, which begin at at 2,400, its border, which begin at 2,400 kilometers from the surface of the sun, and or other stars at the same statue, so which have a similar volume and up to about 482,082 kilometers away. And this outer zone, it is in perfect agreement with atoms, which undergo here and there and on all the surface of the star or the sun, where one atoms at a time is to undergo at the first opportunity a thermal shock which break at the same time all its bounds of strong interaction and other which are weaker, which serve to retain its elementary particles together. And when all links of strong interaction and other that are weaker are broken, that's produce different radiation. Strong radiation with this when it's break the strong links, and the weaker radiation when it's break the weaker link. So, and when a considerably hot atom, which can be up to 15 million kelvins, and which originate from the interior of the sun, happen to come into contact with the thermal temperature which is only 5,781 kelvins. This encounter with an external temperature which is by hypothesis about 14,994,219 kelvins lesser hot. It is so violent that it has the consequences of subjecting to considerably hot atom to a thermal shock which is sufficient violent, so that is as the consequences of breaking at the same time all of the strong interaction bonds and other which are weaker of atoms, which serve to hold its elementary particles together, and all the links of the strong interaction and other that are weaker are broken. This has the consequence of producing a violent separation and a violent burst of all the elementary particles in such a way as to violently move them away from each other and from the surface of the star or the sun, while producing at the same time a number of level of radiation energy which is equal to the number of elementary particles released, and among them level of radiation energy that vary between strong and others that are weaker. So yeah, so that it is here. So and so so for me the sun have 4 zones. The atmosphere of the sun have 4 zones. The first one is the photosphere. The second is chromosphere. The third is solar corona, and the last one is heliosphere. So, and that it is. And I just invent today a new ideas about to explain why different temperature, because that's what happened here. The temperature, the sun inside in the middle is 15 millions, which is number 1. This is the parts of the sun. And so if the middle of the sun is 15 million Kelvin, at its surface it should be much more higher than only 5,000, of only 5,781 Kelvin doesn't make sense for me. So that's why the zone here, the photosphere, is out of the sun and don't have a real contact with the sun, because it's different. The sun it's a liquid matter, and the photosphere it's a gas. So between gas and liquid they doesn't have direct transmission. So that's why then the photosphere was not a part of the sun for me. And after this is the chromosphere, which is here, so the photosphere is 400 kilometers thick, and the chromosphere is 2,000 kilometers thick. And corona is much more bigger, so it's so large that it can go over here. So and the heliosphere, so of course it's much further, so of course I cannot put over there too. So that it is. Then so what I just invent today, it is when each nuclear fission occurs of the surface of the sun due to a cooling thermal shock of a difference of about 14,994,219 kelvins, or a little lesser, like in Celsius, which is cooler, which is difference of cooler. So you know, a difference of about 15 million Kelvin cooler, or most likely from a cooling thermal shock of a difference that is less than about 15 million cooler, but maybe, I don't know, 13 million cooler. So a difference of 10 or 13 million cooler. It's a lot, it's a huge difference. So but remains so anyway, so what is the real temperature up there? We don't know actually, but it's something to remind, but so it's neat, but remains to be determined later then. So and so that each explosion by natural nuclear fusion result in the instantaneous production of a vacuum, and this instantaneous vacuum is at a neutral or more or less neutral temperature, with the consequences of considerably reducing the ambient temperature at a relatively short distance from the sun. So probably this vacuum makes this temperature, help to make this temperature much lower than the sun then. And it is the formation of this, and it is the formation of this punctual vacuum of each of the explosion in natural nuclear fission, not fusion, fission, sorry. Fission of all these atoms, which undergoes this instantaneous explosion. Yes, because here it's not fusion, it's natural nuclear fission and not fusion. So then, and of several others atoms which undergoes its explosion in a natural nuclear fission, one after the other, so as to reproduce in a continuous way this drop in local temperature. The fact that their natural nuclear fission explosion occur instantaneously, the production of their intense heat manifests itself only behind the small photospheric zone and up to a maximum of about 5 million kelvins at the other boundary of the solar corona. Okay, so that makes sense. Here, the vacuum is probably produced over here. So, and which this vacuum, it's with a low temperature that's produce a drop temperature, and all the fission, the instantly natural fission of all the atoms at the same time, so they keeps produce their heat after, because yes, those natural nuclear fission, it's produce himself instantly. So because of this, they have no times to produce their temperature at close to the sun. So that's why this zone, the temperature is so low compared to the sun, and compare after to the solar corona, which is about 5 million Kelvin. So that's why this temperature is low, and that's why the atoms, when they get in contact of there, they receive a thermal shock, which they break them in a natural nuclear fission. So that's what happened. So that's why it's happened this way, and that's because that's produced a vacuum. That's made the temperature much lower than the sun and the solar corona. So, and in conclusion, it has nothing to do with ultra simplistic nuclear fusion, because it does not exist. So thank you for this video, and see you to the next video.